Everyone, welcome to the area of vibration and air lecture series. Today we are going to discuss about the logarithmic decrement. During the underdamped vibration, the system will get decay when this cyclic process is taken place. So this is a ratio between the amplitude between the two successive motion of the system. So it is the let us take logarithmic decrement as the ln of x1 by x2. It means that in a underdamped condition, the system oscillation will decay over a period of time. So this is the time taken as the damped time, and you have this is the damped vibration, and this will be the decrement of this motion of the system of any mechanical system. So the primary amplitude will be this is the x1 amplitude, and to successive one over another will be it will be decaying over a period of time. That is due to damped time. So let us take in a solution x equal to a e power of minus omega n t with respect to sine. The solution will be a e power of minus zeta omega n t and sine omega n root of 1 minus zeta square. This is because of underdamped condition plus the phase angle will be 5. Right. So let us take this solution for this each successive amplitude that the system is getting decay over a period of time. And we are going to measure what is the decrement rate in terms of logarithmic value. So this solution can be taken as per x1 as well as the x2. X2 will be the this is due to this x and this x1. X2 is get reduced due to the damped time. So we have to add the damped time also here. Damping ratio, damping time plus damped time, normal time to damped time. And sine omega n root of 1 minus zeta square sine. So the ratio between these two successive amplitudes called as the logarithmic decrement. So if you apply, you get a e power minus omega n t sine of omega root of 1 minus zeta square plus 5 whole divided by a e power minus zeta omega plus t. Here we are getting a t because of damped time. Again the sine omega root of 1 minus zeta square plus 5. This we can eliminate the same term and we will get logarithmic decrement ln is equal to ln of e power of minus zeta omega n t divided by e power of minus zeta omega n t plus t. This is t plus t. So again, we will take common term, we will get e power of omega n. This is how we will get once we get the value. So this logarithmic delta equal to ln of e power zeta omega n, and this is td damping. So now we can cancel this ln and exponential term. We get logarithmic decrement as zeta omega n to td. This is damping time, where the damping time will be 2 pi by omega root of 1 minus zeta square. Now if you want to replace this td here, again we get the logarithmic decrement delta will be zeta damping ratio natural frequency omega n 2 pi by omega n and root of 1 minus zeta square. Right. So zeta 2 pi root of 1 minus zeta square